Sahil best.
But the match was good. And don't miss. I saved 2 shots of yours, Sahil.
Guys, can we stop talking about football? We have a physics test tomorrow. Let's get serious.
Oh yes.
Is Serious available in the market or what?
Why so serious, guys?
Hey Pratyush, why did you come for the PT period today?
I didn't come because I wanted to study physics, but everything just flew over my head with terminal velocity.
That was a wrong application of terminal velocity, Pratyush. It only happens in fluids. Remember that.
Hence proved I don't know anything.
Don't worry, buddy. We'll help you out. Tell us your problems.
The theory is too bulky for me, and the NCRT just confuses me further. What do I do now?
I think we have a solution to your problem. We can help you understand practically. That's a 100% efficient idea. Let's start with EMI, which has got the maximum weightage in tomorrow's exam.
Yes.
Yes, EMI. And that is to electromagnetic induction and not equal monthly installments.
Listen, what happens is due to the change in magnetic flux. Flux? Or the surplus?
Very bad joke, Sahil.
It is defined as the number of field lines crossing per unit area.
Mudit, you are helping. I just hope my previous knowledge does not dissolve out of me.
Let's understand this practically. Before understanding the meaning of magnetic flux, let us understand the meaning of flux. Flux is anything per unit area. There are several types of flux. For water flux. Here water is flowing in a pipe from one end to the other end. The volume of water which flows through this end is referred to as water flux. This could be understood by an easy example. Consider this as a unit surface, the smaller square, and the area vector is perpendicular to the surface, that is normal to the surface. We have this pencil and we strike it along the normal to the surface and see that it is passing through the maximum chance. But if we make an angle of 90 degree with the normal, then there is minimum chance of this passing through. This can be easily shown in the formula of magnetic flux. Magnetic flux is denoted by the Greek alphabet phi or phi b, where b represents the magnetic field strength. Its formula is B multiplied by S multiplied by cos theta. S is the unit surface through which the field lines are passing. Cos theta is used to show the angle which the magnetic field lines make with the unit surface. If it is 0 degree, it is maximum as we have just seen, and if it is 90 degree, there is minimum chance of these fields to pass through, and thus minimum magnetic flux. The SI unit of magnetic flux is Weber, represented by the symbol WB, and its CGS unit is Maxwell, named after the great scientist James Maxwell.
Okay, that was a little help. But isn't our test on EMI?
EMI was discovered by one of my favorite scientists, Michael Faraday. He threw the magnet in frustration after several failed attempts and observed a deflection in the galvanometer.
Didn't he also give some laws?
Michael Faraday's laws. I'll help you with that, Pratyush. Michael Faraday gave the laws for electromagnetic induction, that is EMI. Faraday gave 2 laws. The first law is as follows. Whenever there is a change in magnetic flux linked with the coil, an EMF is produced in the coil. The EMF lasts in the coil as long as there is a change in the magnetic flux. Michael Faraday's second law states that the EMF produced is directly proportional to the rate of change of magnetic flux. Now let us show that via a mathematical equation. Thank you. E, which is the EMF produced, is equal to minus d phi by dt. That is the rate of change of magnetic flux. The negative sign indicates that the EMF produced always opposes the rate of change of magnetic flux.
Where are these laws used?
In the Supreme Court!
Sahil, don't worry Pratyush, I'll help you out with that. You'll understand it much better. Remember Pratyush, what happened with Akash and Rajdeep the other day when they went to Electromagnetic market? So friends, let's talk about a very important and of course a very interesting application of electromagnetic induction, that is, we'll talk about metal detectors. We've all seen metal detectors at many places such as metro stations, railway stations and of course airports. And we've all followed this custom of standing in a queue and one by one entering into the metal box for checking up. Now what happens when we enter into the metal detector? If a person entering into it carries any metal with it, the metal detector detects it and sets up an alarm and the person gets caught. So now let's understand what a metal detector is and how it works. A metal detector is a very electrical instrument that works on the principle of EMI and is used to detect metals. Now let's understand how it works in a very simple manner. A metal detector consists of an oscillator producing an alternating current that passes through this coil, producing an alternating magnetic field. Now if a person carrying any electrically conducting metal, let's say iron for example, and current gets induced into the metal, and of course a corresponding magnetic field also gets induced in it. Now if we take another coil just to measure the magnetic field that acts as a magnetometer, the change in the magnetic field of the coil due to the presence of metal can be detected, and thus sets up an alarm and the buzzer buzzes and the person gets caught. So this was the working of metal detector. Now let's understand the applications of metal detector. It is not only used in these stations but has many other industrial applications also. It is used in demining, that is detection of lands, detection of minerals, geophysical detection, archaeology and treasure hunting. So friends, finally, you all have to be more than smart to get away with your metal objects when you enter the metal detector.
Are there any other applications of EMI?
As a matter of fact, there are many applications of it. It is as useful as food in our lives. These include AC generator, transformers, induction motor, induction cooker, etc.
And I think there's one more application, and the concept of mutual induction. What is it actually?
Mutual induction? Why am I suddenly failing? I'm sitting in the commerce class.
We'll help you later, Pratyush.
Mehul, first help me solve my doubt. The other day, I saw heavy metal objects being picked up by a magnet. I'm not sure, but is it another application of mutual induction?
Not really, I think. Guys, give me an opportunity to explain. There are several uses of electromagnet in our day-to-day life. Now, I'm going to show you how to make an electromagnet. For this, we are using a circuit consisting of a switch, an iron nail, copper wire and an LED. To understand it in a better way, we draw the following diagram in which a voltage of 4 volts is applied to the coil. And as long as the current passes through the coil, there is a strong magnetic field produced inside the coil, magnetizing the iron nail which is placed inside the coil. The iron nail behaves like an electromagnet till the current flows through the coil. And when we switch off the current, the magnetic effect vanishes away.
Oh, I see. By passing your information through me, I feel like a knowledge magnet.
Don't forget, a temporary magnet.
Hello? I think I'm forgetting something. Mehul, you have to explain mutual induction to me.
Oh, now let's proceed with mutual induction. Mutual induction has many applications in daily life. The gadgets we use at home all use the concept of mutual induction. But you'd be wondering how that is possible. That is possible by the device known as transformer. What it does is, it steps down the voltage coming from the power source. It is actually very high, 220 volt enters our house. But gadgets work at 8 volt, 10 volt, minimum voltages like that. So how it works is, let me explain it to you by a diagram. This is the diagram of transformer. Here, this is the primary coil, and over here I am showing you the secondary coil. The primary coil gets an input from the AC source, that is VP, that is the primary voltage, and secondary coil transmits a voltage that is Vs. Now this voltage is used in our devices. This is given by the formula
Ns by Np. That is the number of coils in this number of turns in the secondary coil upon the number of turns in the primary coil, which is equal to the voltage in secondary coil upon the voltage in primary coil, which is equal to the current in primary coil upon the current in secondary coil. This is known as the transformer ratio. Here we see number of turns in secondary is directly proportional to voltage in secondary. Now when high voltage comes into the primary coil, by using the low number of turns in the secondary coil, the voltage is stepped down. This is how we are able to use gadgets in our homes.
Say it, buddy.
So Pratyush, now you can transform into an intelligent being.
That was a very bad joke, Sahib.
Thanks guys, so far so good. There was one thing which I couldn't comprehend. AC generator.
Oh, AC generator? Oh, that's my favorite topic. I'll explain it to you. Hey friends, today I'm going to explain the principle and working of an AC generator. The main question is, on what principle does an AC generator work? The principle on which the AC generator works is EMI, Electromagnetic Induction. To understand its working, we have two prototype working AC generators. The first one, in a fixed coil, a magnet rotates. When it rotates, as you can see, the LED glows. This is because of induced EMF in the coil. In the second generator, the coil rotates with respect to the stationary magnet, which also results in LED glow. As you can see, the LED here glows. The $1 million question is, how does current gets induced in the generator? To understand this in a better way, we have this diagram. Here we can see in the diagram, these are two pole ends of the magnet. In this is called the armature coil, which is free to rotate. These are called the slip rings, and these are basically to conduct electricity. These are connected to a galvanometer to see the current. When this rotates, there are some magnetic field lines between the two poles of the magnet, the north and south poles. When this coil rotates, the magnetic field lines are cut. Because of that, current is induced, and it passes through these wires and comes to the galvanometer, which shows the reading and presence of current. The galvanometer can also be replaced by an LED, which in turn glows, as you can see in this mode.
Okay guys, I feel better now. I think I'm magnetized enough to take on the paper tomorrow.
Good. Hey guys, the test has been cancelled.
Yes!
But I need someone to explain me EMI.
I think I can help you.